Okay, kamusta kayo, class? Okay, that's good to hear. So, Anna, can you lead the prayer? Okay, thank you.
Dear Father in heaven, I hear thy children are here before you. Offer this day all we do think and say. Please give light to our minds, understand our lessons well. Help us to love one another because we are all thy children. Bless our parents in our home, bless our teacher in our school, bless our country, and bring us all to heaven. In Jesus' name we pray. Amen.
Amen! Good day, everyone! Welcome to another day of learning science! Once again, I am your teacher in science and my name is Patricia May Salabao. But you can call me teacher? Yes, Teacher Patty. For your attendance, I want you to raise your right hand and say present when I call your names. Very well, no one is absent, so give your hand up applause. So, for your assignment, bring out your assignment and pass it forward. So, for reminders, pick the papers around and throw it in our trash can. Arrange your chairs properly. And people with a short height, sit in front and nearsighted. Now, listen carefully in the video that I will show you.
About 4.5 billion years ago, gravity pulled a cloud of dust and gas together, which might have come from the explosion of a nearby star called the supernova. So, this massive concentration of interstellar gas and dust created a molecular cloud that would form the Sun's birthplace. Because of cold temperatures, the cloud began to collapse under its own gravity, forming young stellar objects known as protostars. As gravity pulled the gas and dust together, it made the cloud start to collapse, thus forming a solar nebula. As it collapsed, the cloud began to spin. Eventually, the cloud grew hotter and denser in the center, with a disk of gas and dust surrounding it, and it was cooler at the edges. As the disk got thinner and thinner, particles began to stick together and form clumps. Some of them got bigger, eventually forming planets and moons. So, near the center of the cloud, only rocky material could stand the great heat, like Mercury, Venus, Earth, and Mars. While in the outer regions of the disk, icy matter was settled along with rocky material, where gas giants like Jupiter and Saturn formed. As the cloud continued to fall in, the center eventually got so hot that it became a star. Today, we call it the Sun. The new star blew most of the gas and dust of the new solar system with a strong stellar wind. By studying meteorites left over from this early phase of the solar system, scientists have found that the solar system is about 4,600 million years old.
Okay, the video presentation is done. Now, I want you to group yourself into two groups and create group or time chart based on the observation you had in the video of how the universe is formed. So, I'll give you 15 minutes. Okay, time's up. Pin or stick your output in the board. Now, can someone read the objective? Yes, Joanna, please read. Okay, very good. You may now say thank you for volunteering. Now, I will ask some students to perform a role playing. After 10 minutes, the play will begin. There was a star family talking together at night. The mother is sharing the story of how the solar system formed through son and daughter for a midnight story.
The solar system is a pretty busy place. It's got all kinds of planets, moons, asteroids, and comets zipping around our sun. But how did this busy stellar neighborhood come to be? Our story starts about 4.6 billion years ago with a wispy cloud of stellar dust. This cloud was part of a bigger cloud called a nebula.
La 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 la. Oh, a star. I guess there's something wrong with it. Hey, are you okay? No, don't come near me. I don't feel good. I think I'm about to explode.
At some point, the cloud collapsed, possibly because the shockwave of a nearby exploding star caused it to compress. When it collapsed, it fell in on itself, creating a disk of material surrounding it. Finally, the pressure caused by the material was so great that hydrogen atoms began to fuse into helium, releasing a tremendous amount of energy. Our sun was born.
It feels like I've been asleep for a long time. What a beautiful view.
Even though the sun gobbled up more than 99% of all the stuff in this disk, there was still some material left over. Bits of this material clumped together because of gravity. Big objects collided with bigger objects, forming still bigger objects. Finally, some of these objects became big enough to be spheres. These spheres became planets and dwarf planets.
I'm Mercury. I am Venus. Hey guys, my name is Earth. I am Mars. You can call me Jupiter. I am Saturn. Nice to see you. Uranus is my name. You can call me Neptune. Nice to know you guys. I guess I'm a dwarf planet. My name is Pluto.
Rocky planets like Earth form near the sun because icy and gaseous material couldn't survive close to all that heat. Gas and icy stuff collected further away, creating the gas and ice giants. And like that, the solar system as we know it today was formed. There are still leftover remains of the early days, though. Asteroids in the asteroid belt are the bits and pieces of the early solar system that could never quite form a planet. Way off in the outer reaches of the solar system are comets. These icy bits haven't changed much at all since the solar system's formation. In fact, it is the study of asteroids and comets that allows scientists to piece together this whole long story.
Oh, they're now asleep. Sleep tight, little sweeties. Okay, did you take note some important details about the play? For your demonstration of learning, I will ask two members of each group to discuss the graph and the observation of the play, while the other members may add additional information about the report. Okay, please give a hand of applause, each and everyone. Did you enjoy the activities? Very good. I know somehow some of you find it difficult to do some tasks. Now, to test your understanding and knowledge of the lesson, I'll give a long quiz. So bring out your quiz notebook and answer the following questions. You only have 10 minutes. Oops, time's up. Raise your pens. Okay, let's check your answers. Answer number 1 is letter A, which is 4.6 billion years. Number 2, A, nebula. Number 3, A, supernova. Number 4, supernova again. Number 5, yes, nebula. 6, letter D, which is counterclockwise. 7, A, accretion. 8, C, yes, and they are still moving. Number 9, A, craters. Number 10, A, Earth's atmosphere protects and weather. Number 11, A, yes, and they don't have a solution to stop them. 12, letter B, which is disk. Okay, pass your paper so that I could record it in my grading sheet. Very well participation, students. You did well today. Now, take note for your assignments. That's all for today. Goodbye, class. See you around.